Yo, it's Professor McStud is in the house. So we're talking about multiplying monomials and polynomials, and we are going to kind of mesh all those together. What does that look like? And so here we are. We're starting here. We have two binomials. When you have binomials, you do the FOIL method. B times B becomes B squared. Negative 4 times B is negative 4B. Outside, plus 6B. Last, we have negative 4 times 6 is negative 24 here. So B squared plus 2B minus 24. That's your final answer. So remember, FOIL, binomial. Here we have a binomial times a trinomial. I like to use the box method. You use whatever you want to do. So here we have 2x squared minus 3x plus 1, and we have 2x minus 1. This becomes 4x squared. Still remember, multiply the coefficients. We get caught up sometimes and forget to do that. Negative 3x times 2x is negative 6x squared, and then 1 times 2x is, again, just 2x. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 3 is a positive 3x is a positive. And then negative 1 times 1 is negative 1. Here, remember, like terms are always going to be at your diagonal here. So final answer here, we have 4. Ooh, I messed up. This is 4x to the third. So 4x to the third power minus 8x squared plus 5x minus 1. Final answer, big, long polynomial with 4 terms. You should have 4 terms at the end of that. Next example, we have 3r times r squared minus 2r plus 4. So this is a distribution. Here, here, here. All right, so we have 3r times r squared is 3r to the third power. This one times this one is, 3r times negative 2r is negative 6r squared. R times r is r squared. And then lastly, 3r times 4 is a positive 12r. That's it. There's no combining after that because there's no other like terms to get together. All right, notice here, these are two monomials I'm going to multiply together. I like to rewrite it with your coefficients first, so negative 4 times 5 first. Then you take your c to the third times c, that's here and here, and then your d times d. So all of that is multiplied together. So don't try to FOIL this. This is not a FOIL problem. This is a monomial times a monomial. We get caught up in FOILing. When we come back to monomials, we try to FOIL it again. So this is negative 20. Then when you multiply, you add exponents. So c to the fourth, and these are like ones, d to the second power. Final answer there. That's nothing else. There's no other like terms, nothing else to get together. That's just it. On this one, so here, remember the 7 doesn't get this square doesn't apply to that 7. Order of operations say I must do exponents first, so that exponents comes to this first. So I have 7 times 3 squared, x to the 1 times 2, or just squared, and then y to the 2 times 2. I'm going to simplify in here before I start multiplying by 7. So that's 7 times 9, x squared, y to the 4th. Then all that is now is multiply these coefficients. That's it. Because there's monomial times a monomial. No FOIL, no none of that. So final answer, I have 63x squared, y to the 4th. Final answer. Lastly, example 6 here, we have 2k squared times k. So there's like a 1 here. If you want to do 2 times 1, you can do that, then k squared times k. Back here, this is a 1. When you multiply, you should add the exponents. So therefore, I have 2k to the third power. That's all. That's it. So misconceptions here is that we FOIL when we have monomials. Do not FOIL when you have monomials. So one term. Remember, we kind of talked about that. Polynomials are separated through addition and subtraction signs. So make sure that you do not FOIL when you're going through multiplying monomials. Only FOIL when you have binomials, trinomials, that kind of thing. So that's it. And Professor McStud is out.